Welcome to this tutorial on cross macros. I first learnt of cross macros, often written as xmacros, from articles on embedded.com by Andrew Lucas. The links can be found with this video. Andrew's articles are very interesting and are recommended, but a slightly different macro naming convention is used in this tutorial. I started using the cross macros technique and appreciated one of their advantages in making C and C++ enum types more maintainable. After discussions with my then colleague Mark H., we worked out an alternative, simpler way of calculating the maximum number of enumeration values than that used in the articles. We'll use the revised method in this tutorial. So, without further ado, what problems are we trying to solve? Here we have a typical enumeration which we can find in much production code. Note, in this C fragment we're using a prefix mcet_ to mimic C++ namespaces. The type contains a comment on where to add new enumerations, and if respected, the maxlen value will automatically contain the number of enums, so long as the zero-based default enum integer representation is used, as here. Otherwise, you need to explicitly set the maxlen value. This is obviously nasty, as the maxlen token doesn't really belong in the enum type. It's an attribute of the type, not an enumeration value. We also have a comment to remind us to update a function. Can this short list of functions be trusted? Let's look at an example function that has an argument of our enum type and returns a string representation of the value and now needs to be updated. It's been implemented using a switch statement. There's a comment to remind coders on where to add new case branches. The char pointer values returned are just the enum value manually rendered as a literal string. We can see this type of implementation quite often in production code. It's alright, but tedious to write and is brittle. We may have several functions or blocks throughout the code base dependent on the enum type. So if we add a new value, we should address all usages of the type. With a function like this, the compiler may not let us know that our switch statement has missed an enum value. Let's use cross macros to improve matters. First, we define our table, which encompasses all rows and their data columns. Here we've only got one column, the enumeration values themselves. We're going to use the preprocessor to generate the string representation of the enum values. Note that there's no need for a max length row on the end of the table. We will use cross macros to automatically generate that for us outside of the enum itself. The table macro has one formal argument, generate a macro, which we supplied to write code for any particular context. The cross macro technique works by having the table macro, invoke in inverted commas, the generator macro for each row. Therefore, the generator macros need a formal argument for each column of the table. For each code fragment we want the preprocessor to generate for us, we'll supply an appropriate generator macro to pass to the table. So now we need to define our generator macros. Our first generator, mcet enum generator, supplies the enumeration value e followed by a comma, so that it will write a list of enumeration values suitable for an enum type declaration. The last value in the enumeration will have a trailing comma, which you might not write in handwritten code, but it is legal and compiles. Our second maxlen generator macro ignores its argument and just supplies a 1 followed by an addition operator. This is how we calculate the number of enumeration values. For each row of the table, the preprocessor just adds another 1 value. The compiler will then calculate the expression summing all of the ones, giving us the total number of enumerations, the number of rows of the table. Now to declare our new enumeration type. We've used the well-known C and C++ syntax that declares an enum type, but the braces of the declaration contain our table macro, and the enumeration generator macro that we pass to it will write the list of enumeration values for us. As an aid to generating code this way, if you use an editor like Visual Studio Code with the C and C++ extension, hovering over the composers table macro, the editor will show how the preprocessor will expand the table. You can also use the GCC or G++ or CLang's E flag to show the translation unit with its preprocessed output. Now to define our maxlen constant. To do that, we invoke the table macro with the maxlen generator. We need to append a 0 literal after the table/generator to deal with what would otherwise be an invalid trailing addition operator left by the last row of the table. There's an alternative macro definition of the max length that follows the constants declaration. The maxlen value is self-modifying. There's nothing more we need to do to it unless a new column were added. So we have defined our enum and replaced the offensive max length value that was polluting the enum before. What does our enum to string function look like now? We need some additional declarations. We'll implement the function using a data table, and to create the values for that we're going to use a generator to create the string values from the enumeration values. For that we need the preprocessor's stringify hash operator. We also slice off the first 5 characters to hide the implementation prefix mcet_. Our enum to string function is shown. To initialize the lookup table, the cross macro table uses mcet enum to str generator. As a caller can pass almost any integer value as an enum argument, within the function we need to validate the enum's value before using it to index into the array of char pointers. This function's implementation shouldn't need to change if new enumeration values are added, a form of the open-close principle, though the generator would need to be edited if a new column were added. How do we add a new column? Suppose we want more control over the string form of our enumerations. How can we do that now that we're using cross macros? This requires us to add a new column to our cross macro table and amend all of our generator macros passed to the table by adding a new formal argument. Our macros now look like this. To the table we've added the second column, the second generator argument, containing our new text representation of the enumeration. All of our generators require this second formal argument, here named S for string, to be added. The enum and maxlen generators ignore it. mcet enum to str generator supplies the second string argument with a trailing comma to allow it to be used in an initializer to the char pointer array enum as strings table. We just need to rebuild the code and we've finished. That concludes our first look at cross macros and how to use them to improve C and C++ enumerations. I hope you found this video interesting and thanks for watching. There'll be more videos like this coming soon, so please like and subscribe. Goodbye.